Welcome. This section is titled Data Collection and Sampling Techniques. So we have talked about previously the fact that gathering data from an entire population can often be impossible or difficult or just not practical, and we often rely on samples to represent those populations. So we want to make it an effort to ensure that our samples are good reflections of our population. And there are different methods for collecting samples. The decision of which one to use will be based on the particular research question and various circumstances. So here we're just going to focus on essentially 4 different sampling techniques, knowing that there are others out there, and oftentimes different sampling techniques are combined and there can be more complicated processes, but we'll try to keep it simple here. And we'll start with random sampling. So in random sampling, members from the population are selected in such a way that each individual member in the population has the same chance of being selected. So for example, I could put names in a fishbowl, and a teacher, if these were students, could randomly pull out a name, and that student would be passing out papers to the class. So every student has the same chance of being selected. I made a note here that simple random sampling means that any group of the same size would have the same chance of being selected. So perhaps rather than picking one student's name, you would pick 3 students' names. So any group of 3 would have the same chance of being selected. So we'll be sticking just with random moving forward here as we identify techniques. So each individual has the same chance of being selected. All right, our next technique is called systematic sampling. With systematic sampling, we pick a starting value and then establish an interval on which we collect our data. So in my example here, we have a row of houses, and we start at the second house, and then rather than stopping at the whole population of houses on the street, we're stopping at every third house. So for the purposes of our class, we don't get any deeper into this. We're not going to try to figure out why did they start at the second house and why did they choose every third house. We simply want to recognize the technique when we see it. So anytime we've got some type of interval, so in my example here, a researcher has 100 individuals and needs 12 of them. They start at the 5th individual and then select every 8th individual. So when we see an interval selected, this is called systematic sampling. All right. Now, the next 2 can sometimes be confusing because there's a similarity to them, but they are definitely different. So stratified random sampling versus cluster random sampling. So in stratified sampling, we divide a population into groups based on a shared characteristic, and each of these groups is called a stratum. Plural of that is strata. So each group is a stratum. So I'm going to just take my example here. So let's say we have a market researcher. They're going to separate the population into groups, strata, based on their generation. So perhaps we're talking about maybe a conference, lots of people in attendance, and there's baby boomers, there's some Gen X, there's millennials, some Gen Zs, and the researcher then wants to make sure that every generation is represented when she takes her sample. So what she does is randomly selects some members from each of those generations to include in her research. So in stratified, we create groups called strata. So we make groups. So in this picture, I've got 6 groups. And then we take a random selection of members from each of those groups. And this ensures no group gets left out. So for short, I call it some random members are selected from each group. So some members from each. Now notice random is part of the process, so stratified random. So don't think everything is random sampling. Random can be part of other processes. So in random sampling, there's no grouping. Every individual just has the same chance of being selected. In stratified, we've got the grouping going on based on some characteristic that they share. And then at random, we pick some individuals, so some random members from every group. All right, let's see how that compares with cluster random sampling. So in cluster sampling, the population is still divided into groups. Now they're called clusters. And then we take a random sample of clusters and collect data from all members in the selected clusters. So some clusters will not be sampled. The ones that are chosen, we take all members from those clusters. So my example for an agricultural study, a researcher separates a large geographical region into areas or clusters. So perhaps they don't want to travel throughout the entire large geographical region. So what they do is select some of those regions. So out of these 6 regions, they would randomly pick 2 of them at random. These 2 get chosen. And from those regions, they're going to visit all of the farms in those regions. So all of them from just 2 out of those 6 clusters. All right, so some groups are randomly selected, but all members of those groups form the sample. So with cluster, all members are selected from just some of the random groups. So you want to find a way to make sure you see the difference between the two techniques and different ways to think about it. So with stratified random sampling, it's members that are chosen at random. With cluster random sampling, it's the groups that are chosen at random, and then all members are selected from those particular groups. And of course, we'll have some practice on the next page. All right, and then adding a technique here down at the bottom, convenience sampling. So in a convenience sample, there is no effort made to ensure the sample is representative. It's simply doing what is convenient and easy to gather your data. So as an example, a sociology professor is interested in studying drinking behaviors among college students, and the professor teaches an intro to sociology class and uses her class as her sample. So certainly convenient. Her students are right in front of her, but she would only be representing her own students and only students taking sociology. So there is a definite limitation to doing this convenience sample, but sometimes even though they tend not to be representative, they can be a helpful tool in research as well. All right, and then the reality is multi-stage sampling, that it really tends to involve more than one type of sampling. And if that research is required, we would start combining techniques. So before I go on to some examples, I'm just going to return for a moment to my Pew Research article here on gun violence, widely viewed as major and growing national problem. So I had mentioned at the start of chapter 1 that they had collected data from a sample of Americans. And now I just want to point out here, this is what they mentioned in the article about their sample design. So their overall target population for the survey was non-institutionalized persons ages 18 and older living in the United States, including Alaska and Hawaii. So how did they choose the Americans to participate? So it says here that it featured a stratified random sample from it's just their pool of people, in which Hispanic men, non-Hispanic Black men, and non-Hispanic Asian adults were selected with certainty. In other words, they did not want to leave any of these groups out of their study on Americans. So stratified random sample, again, just going to come over to our picture. They chose to do a stratified random sample where they made sure that of these groups that they created, of these strata that they created, that those strata included a strata of Hispanic men and one of non-Hispanic men, Black men and non-Hispanic Asian adults, to make sure they pick some people from each of those groups. So that is our stratified. All right, so that is a summary there of the techniques that we'll be considering. And then on our next page, we'll do a little bit of practicing at identifying those sampling methods.